Early decades of the 20th century, a new set of ideas emerged that shook Newton's stage to its very foundation. Ideas put forward by a young clerk working in a Swiss patent office. His name? Albert Einstein. Einstein grew up in the late 1800s, at the dawn of the age of electricity. Electric power was lighting up cities, giving rise to all kinds of technologies Newton could never have imagined. All of these developments tapped into something that had captivated Einstein since he was a child: light. Not light bulbs and street lamps, but the very nature of light itself. And it was his fascination with one particularly weird feature of light, its speed, that would lead Einstein to overturn Newton's picture of space. To see how, let's take a ride. Right now, we're traveling at about 20 miles per hour. And to go faster, all the driver needs to do is step on the gas, and the cab speed changes. Now, you can feel that change, but you can also see it on the cab speedometer or on one of those radar speed signs. Okay, you can slow it down now. But now imagine that instead of measuring the speed of the cab, you have a radar sign that measures the speed of the light coming off its headlights. That sign would measure the light traveling at an astounding 671 million miles an hour. Now, when the cab starts moving, you'd think that the speed of the light would increase by the same amount as the car. After all, you'd think that the moving cab would give the light an extra push. But surprisingly, that's not what happens. Our radar sign, or any measurement of light speed, will always detect light traveling at 671 million miles per hour, whether the cab is moving or not. But how could this be? How could all measurements of light speed always come out the same?
If you're running at a wall, it's coming at you faster than if you're standing still with respect to that wall. But that's not true with light. The speed of light is the same for everybody. That's really extraordinary.
So here's how Einstein made sense of this extraordinary puzzle. Knowing that speed is just a measure of the space that something travels over time, Einstein proposed a truly stunning idea: that space and time could work together, constantly adjusting by exactly the right amount, so that no matter how fast you might be moving when you measure the speed of light, it always comes out to be 671 million miles per hour.
To respect that absolute quality about light, time had to cease to be absolute, space had to cease to be absolute, and those two had to become relative in such a way that they slosh between each other.
If space and time being flexible sounds unfamiliar, it's only because we don't move fast enough in everyday life to see it in action. But if this cab could move near the speed of light, the effects would no longer be hidden. For example, if you were on a street corner as I went by close to the speed of light, you see space adjusting so that my cab, it would appear just inches long. And you'd also hear my watch ticking off time very slowly. But from my perspective, inside the cab, my watch would be ticking normally, and space in here would appear as it always does. But when I look outside the cab, I'd see space wildly adjusting, all to keep the speed of light constant. So with Einstein, time and space are no longer rigid and absolute. Instead, they meld together with motion, forming a single entity that came to be called space-time.
I think as we live our life every day, we live with a Newtonian picture of space and time. It's something that we are comfortable with. But Einstein was able to make reason conquer sense. And that really was the genius of Einstein.
This notion that space and time our unity, to me is one of the greatest insights that has ever occurred in science. It's so counterintuitive to everything we've ever experienced as human beings.
And in the hands of Albert Einstein, this new picture of space would solve a deep mystery having to do with the most familiar force in the cosmos: gravity. Newton knew that gravity is a force that attracts objects to each other, and his laws predicted the strength of this force with fantastic precision. But how does gravity actually work? How does the Earth pull on the moon across hundreds of thousands of miles of empty space? They behave as if they're connected by some kind of invisible rope. But everyone knew that wasn't true. And Newton's laws provided no explanation.
Einstein found that no Band-Aid patches would fix Newtonian gravity. He had to invent a mechanism for it. He had to understand it.
After puzzling over this problem for more than 10 years, Einstein reached a startling conclusion. The secret to gravity lay in the nature of space-time. It was even more flexible than he had previously realized. It could stretch like an actual fabric. This was a truly